This is a 2013 Pei Secondary School mid-year paper. Okay, question 1. Use the substances named in the table to answer the following question. Name all monoatomic gases. Monoatomic gases are basically the group 0 or the group 8 gases. And you can refer to your periodic table, argon and helium. Okay, so the answer for this is argon and helium. They are found in group 0 or group 8 in the periodic table. Which substances are liquids at negative 187 degrees Celsius? Now, liquid means that this temperature is actually in between melting and boiling point. Liquid means it's melted already but haven't boiled yet. Okay, so negative 187 should be in between melting and boiling point. So for argon, negative 187 is in between negative 189 and negative 186. So argon is one of them. Okay. How about carbon dioxide? Carbon dioxide is not. Helium, negative 187, is it in between negative 270 and negative 269? It's not. How about nitrogen? It's also not. How about oxygen? Yes. Negative 187, it is in between these two temperatures. So the answer for this question is argon and oxygen. Name the substance which is a liquid over the largest range of temperature. Liquid over the largest range of temperature means that the temperature in between melting and boiling point should have the largest range. Because, for example, argon, it is a liquid in between this and this temperature. So the range must be the largest. So for argon, the range of temperatures for it to become liquid is only 3 degrees Celsius. How about helium? 1 degree Celsius. How about nitrogen? It is 14. And for oxygen, this is the largest. It is 36. So the substance would be oxygen. So the answer for C is oxygen. For D, box A represents the arrangement of particles in carbon dioxide at negative 79 degrees Celsius. Draw a diagram in B to show the arrangement of particles in carbon dioxide at negative 77 degrees Celsius. So you have to know at negative 79 degrees Celsius what happened to carbon dioxide. Now carbon dioxide sublimes. Sublimes means changing from, it's a state change from solid to gas. So at negative 78 degrees Celsius, carbon dioxide changes from solid to gas, meaning that at temperature below negative 78 degrees Celsius, which is like negative 79 degrees Celsius, it is solid. That is why it is solid. It is like this. And at negative 77 degrees Celsius, it is above negative 78 degrees Celsius. So it would have become a gas. So at negative 77, carbon dioxide is a gas. So for gas, for the particle model diagram, the arrangement of particles for gases, always remember, only draw 3 particles. And the 3 particles should not be in a regular arrangement, meaning that you cannot draw the 3 particles like that. It is wrong. Also cannot draw the 3 particles like this. It is wrong. So the 3 particles must be in an irregular arrangement like this. Next question, number 2. Choose the best method of separation to obtain the underlying substance in each of the following. Blue dyes from food coloring. This one must be chromatography. Okay, for A, the answer should be chromatography. Copper to sulfate crystals from its solution. So crystal from the solution. So there will be crystallization. Now for C, iodine from a mixture of iodine and sodium chloride. Now when you see iodine, you want to obtain iodine, you have to know that iodine also sublime. Meaning that iodine will change from solid to gas form. Okay, so in order to obtain iodine, you have to use sublimation. When you heat a mixture of iodine and sodium chloride, which is your common salt, it will melt. But for iodine, Okay, iodine at room temperature and pressure, it is a solid. When you heat it, it will become gas. So basically it's like this. If you have a beaker containing a mixture of iodine and sodium chloride, if you heat it, okay, the focus is not very good. If you heat it, basically what will happen is the iodine will sublime, whereas the sodium chloride will melt. Iodine sublime, that means you get some iodine film, okay, in gas form. And then in order to collect the iodine, you have to use either an evaporating dish or a small piece of glass, okay, at the top. And glass, glass has a very cold surface, so when the iodine gas touch on the surface of the glass, it will be condensed, and then there will be solid iodine particle being formed on the surface of the glass. Basically it will stick on the surface of the glass. Okay, so solid iodine, heat it, become iodine gas. Then after that, iodine gas will condense on the cold glass surface to become iodine solid again. So this is how to obtain iodine, through sublimation. Okay, solid to gas, then after that, okay, there will be sublimation. So you have to take note that only for solid carbon dioxide or dry ice, iodine and ammonium chloride, these three substances, they will sublime, meaning that they will change from solid to gas. Pure water from salt solution, this one will be distillation. Now take note that this is not evaporation. Evaporation is basically to obtain salt from the salt solution. Evaporation is to obtain the salt from the salt solution. If you want to obtain the water from the salt solution, you have to use distillation. Because for distillation, the apparatus is like this, right? Okay, this is the apparatus for distillation. What you will obtain here is the pure water, not the salt. The salt will be here. But what we collect from this distillation is the pure water, which is here. Okay, next question is about bonding. This information comes from a website about salt. Salt contains the compound sodium chloride. Single salt crystal consists of a vast ionic lattice or crystal lattice of sodium and chloride ions. So for ionic compound, so common salt or sodium chloride obviously is an ionic compound. In solid form, all the sodium and the chloride ions, they are all in a crystal lattice format like this, or structure. The lattice structure means that the salt crystals have regular shapes and high melting point. The lattice structure of sodium chloride is shown on the right. A very important use of salt is to provide blah 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 blah. Okay, then let's go to the question. Explain why sodium chloride can conduct electricity only in molten state but not in solid state. So you have to explain in solid state what happened to the sodium chloride. In particular, what happened to the sodium and the chloride ions. Okay, in solid state. Then after that, in molten state, what happened to the solid, what happened to the sodium and the chloride ion. Okay, so your answer will sound something like this. In solid state, the ions are held together in fixed position or in the crystal lattice structure and cannot move. So this is a keyword. The ions are not free to move about. In molten state, then the ions are free to move and hence can conduct electricity. Okay, so this part is basically taken straight out from the bonding mind map. Okay, this page of the bonding mind map is extremely important. The page 3 of the bonding mind map, it will tell you why certain compounds, they have high boiling point, and then the other substance, the other compound has a low melting point, and why. Also, it explains ionic and covalent substance, whether they conduct electricity, or not, and why. So this page of the mind map is very, very important. Okay, the next question is on explain why sodium chloride has a very high melting point. So the high melting point is because of the forces. And what is the name of the forces? You have to know. So the sodium chloride is held together by strong electrostatic forces of attraction between the ions. Okay, a large amount of energy is needed to overcome these strong bonds. So 1 mark here and 1 mark here. Okay, again, this is taken straight out from the third page of the bonding mind map. Then after that, draw a dot and cross diagram to show the bonding present in sodium chloride. So the first thing is you need to recognize that sodium chloride is an ionic compound. An ionic compound, if you want to draw the dot and cross diagram, there must be the square bracket. Okay, it must have square bracket, and then there must be a charge here. Okay, so if you draw one positive charge, the other one must be negative charge. Something like that. So this is the answer. This answer is actually slightly wrong because the question asks you to show the outer shell electrons only. So no need to show the inner shell. Basically just show the most outside shell or the valence shell. Okay, then of course don't forget about the legend. Okay, question 4. The figures below show the electronic structures of 6 atoms A to F. Now, very important to recognize what is the meaning of atoms. Atoms means number of proton is the same as the number of electron. Proton, electron, same number. Meaning that it is neutral. Okay, there is no charge, no positive or no negative charge. They are neutral because the number of proton and number of electrons are the same. Now let's look at the question. Which atoms are isotope? Now, so you have to know the definition of isotopes. Okay, even though this question doesn't ask you the definition, but you need to memorize the definition for isotopes because the question may ask you define isotope. So isotopes are atoms of the same element with the same number of protons but different number of neutrons. So the number of protons must be the same. Number of protons must be the same and the number of neutrons must be different. So it would be this and this. So the answer is B and F. Okay, for A1, the question is B and F because these two atoms have the same number of protons, which is 12, but different number of neutrons, which is 14 and 12 respectively. They have the same nucleon number, so you need to know what is the meaning of nucleon number. Nucleon number is the same as mass number, which is number of proton plus number of neutron. Nucleon number is the number of proton plus neutron. They have the same nucleon number, so you have to add up these two numbers together and see which atoms have the same. So the answer should be A and E, A and E. Because if you add up these two numbers, it's 40, add up these two numbers is also 40. So 40, 40, nucleon number 40, nucleon number 40. That means that the answer should be A and E. How about for part B? Which atom has a mass twice that of atom D? Mass. Mass is the same as the nucleon number, which is the number of proton plus neutron. So you have to find out what is atom D mass. What is the mass of atom D? Atom D, the mass is 12. Okay, twice that of atom D, which is 24. So which one? The nuclear number is 24. So that would be F. So the answer is F. Which atom has a mass twice that of atom D? The answer is F. Because the mass number is 24. Using the periodic table, identify element D. Now, when it comes to identifying element D, you have to look at, if you want to identify an element, you have to look at the proton number. Look at the number of proton. So for D, what is the proton number? 6. Then after that, you have to go to the periodic table, look at the bottom number, which element has the proton number 6, which is carbon. So this one is carbon. Then atom A has an isotope Q with a nuclear number of 38. Atom A has an isotope Q. Now, you need to know that this isotope Q, it has a nuclear number of this. Again, nuclear number is number of proton plus neutron. Now, when it says isotope, it must be atoms of the same element, meaning that Q and A are of the same element. Same element means same proton number, meaning that Q and A have the same proton number. So what is the proton number for A? 18. Meaning that for Q, it would have 18 proton as well. Now 18 proton, nuclear number is 38. Nucleon is proton plus neutron, meaning that the number of neutron would be 38 minus 18, which is 20. So deduce the number of neutrons in Q, that will be 20. Alright? So it's very important to recognize that isotopes, it must be of the same element. Same element means what? Same number of proton. Now let's look at number 5. The drawings A to H represent the particles in 8 different substances at room temperature and pressure. Which of the diagrams best represent the following? You may give more than one answer for each blank. So first one, an element made of single atoms. One atom only. That means monoatomic. That will be C. Monoatomic. It's an element, not a mixture. This one is a mixture of 2 elements. How about a mixture of 2 elements? That would be B. Okay? A pure compound. This is a pure compound because this and this are the same. This and this are the same. So all these 3 are the same. They are all compound and they are pure compound because there isn't other compound here. How about mixture of 2 compounds? This would be the mixture of 2 compounds. Actually, this one or this one. Because this one is one compound, this is another compound. So it's a mixture of 2 compounds. Likewise for this. Since these 2 are joined together. Okay, so this is one compound, this is another compound. So it's a mixture of 2 compounds. Alright? So when they join together, that means they form a compound. When they don't join together like this, okay, it's a mixture. Okay, no problem.